Today, we look into another interesting topic called time, speed, and distance. So, in this topic, we come across problems like calculating the speed or the time and the distance. So, first of all, we need to understand the common relation that exists among these three variables, that is, the time, speed, and the distance variables. See, these are the kind of problems which we come across in this lecture. See how to find the speed of the car. Say the car starts from its initial point and it is traveling towards this final point. Let us assume this building as an initial point and the tower as the final point. Now the car has to travel this distance. So we know the distance and also the time that is taken by the car to reach that final point. So now we know the distance as well as the time taken by the car. So now we need to calculate, we are supposed to calculate the speed of the car. So this is one kind of problem. Let the other kind of the problem be in this way. So we can put in another way, say there is an aeroplane which travels from Mumbai to Delhi. So here we know the distance, that is the distance between the two stations, say Mumbai and Delhi, and now we need to and also the speed of the plane and at which kilometer or miles per hour the plane travels. So we know the distance as well as the speed. So now we are supposed to calculate the time taken by the aeroplane to reach Mumbai from Delhi. So this is another kind of problem where we need to calculate the time. And the third scenario is, see, there is a cyclist who travel round the hill. So now we know the speed as well as the time taken by the cyclist. So we need to calculate the distance traveled by the cyclist. So because we know the other two variables, namely the speed and the time, and now we have to calculate the distance traveled by the cyclist. So these are the three kind of problems which we come across in this type of in this topic. So the basic formula. So before getting into the problems, we need to, this is the only one formula which we use throughout the session to solve any kind of problems. So this is the formula what we have to remember, that is distance is equal to speed into time. This is the basic formula. This shows the relation between these three variables, that is distance is equal to speed into time. See, another problems which we are going to look into the session is the problems or the concepts related to trains. See, we come across four different problems in trains. The first scenario is, see, there is a train. The train has to cross this man who is sitting on the platform, or so who is standing on the platform. The man is idle. So now we need to know the train is supposed to cross this man who is standing on the platform, and we need to calculate the length of the train. This is one kind of problem what they'll ask. And the other kind is, there is a train which crosses the bridge where the bridge is idle. So it crosses the bridge in, say, some 50 km/h speed, and now calculate the length of the length of the bridge, or the length of the train, or the total distance traveled by the train. So they can ask in that way also. Or the third type is, both here in the first two scenarios, if we look into it, only the train is moving whereas the object is idle, that is, it's stationary, it is not at all moving. Whereas in the third case, the train is moving as well as the man is also running, that is, both the objects are in motion. So now we have two different speeds, isn't it? The train will be traveling in one speed, say 50 km/h, whereas the man traveling at another speed, say 10 km/h speed. So we have two different speeds over here, and now here we have to calculate the relative speed. In such a way they can ask you a problem. And the fourth concept is, there are two trains, and the two trains may be either moving in the same direction, but in this diagram I have shown you that the two trains are moving in the opposite direction. One train from station A to station B, whereas the other train from station B to station A. So these two trains are moving in the opposite direction, and we are supposed to calculate the relative speed of these two trains. So these are the four different types of problems what they might ask in the concept of trains. So now again the basic relation what we have seen earlier. See the relation between these three variables. I have already told you that it is distance is equal to speed into time. From this formula we can derive three cases. See case 1. Case 1 is if the distance is constant. Suppose the distance traveled by a particular object is constant. Say a train or a car is traveling from Coimbatore to Chennai. The distance between Coimbatore to Chennai is 300 kilometers. So that distance is constant. And if the distance is constant, then the speed, the remaining two variables are speed and time. The relation between these two can be derived as the speed is inversely proportional to the time taken. Speed is inversely proportional to the time taken. I will explain you this scenario with the help of a diagram. We will move to the second case. In the second case, if the time is constant, say for example you are traveling in you are going to travel different distances, whereas the time is constant. That is both the trains are starting at the same time, isn't it? So here the time is constant. So what about the rest two variables, the distance and the speed? They are directly proportional to each other, say if the time is constant. And the third case is if the speed is constant. If the speed is constant, then the same thing, that is both the car are traveling at the same speed, say 40 km per hour speed. So here the speed is constant. So the other two variables, that is the distance and the time, are directly proportional to each other. These three cases, you might wonder how to understand this, but I'll explain you once again with the help of a diagram. See first case 1. Case 1, let me take speed as a constant variable here. If speed is constant, as I already told you, that distance is directly proportional to time. See, everything depends on this basic formula. Okay, we are not using any other formula, only this basic formula. From this formula we derive all these cases. So in the case 1, we assume that the speed is constant. So the rest variable is d1, which is distance of the first train, and t1, which is the time taken by the first train. d2 is the distance traveled by the second object or the second train, and t2 is the time taken by it. So here the distance is directly proportional to the time taken. So how we can compare the ratios? See, the ratio of distance is equal to the ratio of time taken. If the speed is constant, we can always assume this case that the ratio of their distances traveled by them is equal to the ratio of time taken by them. So here the distance as d1 by d2 is equal to t1 by t2. See, this is the ratio comparison. This is the first case, and there is an example for this first case also. See, listen, here we have a train or a truck. Yes, we have a truck starting from point A, okay, and it travels from point A to point B. The distance is 20 kilometer. It covers this 20 kilometer distance in 40 minutes. So you know the distance as well as the time taken. Similarly, from point B to point C, the same truck is traveling. Now the truck is at point B. From here it has to reach the final destination, that is C. Now the distance between this intermediate point B and the final point C is given as 30 kilometer, and we need to calculate the time taken by the truck to travel this intermediate distance, that is between the point B to C. Is it clear? I think this diagram is very clear. See, I'll explain you the scenario once again. That is, the truck is initially it is at point A. From A, the truck is moved to the intermediate point, say B. The distance from A to B has been given as 20 kilometer, and the time taken by the truck to cover this distance is given as 40 minutes. Okay, and now the truck is at point B. Yes, from here it has to reach the final point C. So now we need to know what is the distance between B and C. That is also given in the problem, that the distance between these 2 points are 30 kilometer, but the time taken is not mentioned. So that is, we are supposed to calculate the time taken by the truck to cover this particular distance. So here we can assume that the speed is constant. We can assume that the speed is constant. If the speed is constant, then whatever the assumption is, the distance traveled by the train, the ratio of their distance is equal to the ratio of the time taken. This is the assumption what we are going to have. So the ratio of their distance is equal to the ratio of the time taken. So let me assume that this is distance 1, d1 as 20 and t1 as 40. Similarly, d2 as 30 and t2 as x, or t2 as it is. So now just substitute the values in the ratio comparison. So that is d1 by d2 is equal to t1 by t2. That is, we have compared these two ratios. 20 by 30 is equal to 40 by t2. Once you solve this equation, you will get the value of t2 as 60 minutes. So the time taken by the truck to travel or to cross this 30 kilometer distance is 60 minutes. Is it clear? So here we assume that the common point, that speed is constant. So we can directly equate the distance and the time taken because they are directly proportional to each other. This is the first case. Now we move on to the second case with the same basic formula, and in this case we are going to keep the variable time as a constant one. So if the time is constant, what we can infer from this, that is, if the time is constant, then the distance is directly proportional to speed. The distance is directly proportional to the speed. So if it is directly proportional, the same case. So the ratio of these two variables can be written as d1 by t2 is equal to s1 by s2. So the ratio of distance traveled by the object is equal to the ratio of their speeds, since the time is constant. So this is the assumption what we have to remember. So for this case, there is another example. See, there is you can see from the diagram that there are two cars. One car is starting at the point A and the other car starts at the point B. Provided, remember that the time is constant, which means both the car starts at the same time. See here, if car, that's yellow color car, if it starts at 4 o'clock, the blue color, the race car will also start at 4 o'clock. So the time is constant here. And the speed of the car is also mentioned in the problem. That is, the car, that is this one, the yellow car, the speed of the yellow car is 50 km per hour and the speed of the other one is 75 km per hour. So here the time is constant, the speed is mentioned, and we need to calculate the distance. We need to calculate the distance, that is, when do these two cars meet each other? That is the question asked. So the speed of the individual cars are given, and they have also given a clue that both the cars start at the same time, which means that the time is constant here. And now we need to calculate when the point at which these two cars meet each other. We need to calculate the point or the time at which these two cars meet each other. Okay, so here, since the time is constant, again we can directly equate the ratio of the distance is equal to the ratio of the speeds. That is, d1 by d2 is equal to s1 by s2. We know s1 and s2. Isn't it? S1 is the speed of the first car, s2 is the speed of the second car. Just substitute here, you will get d1 by d2 as 2 by 3. That is the ratio of the distance, 2:3. This is the example for the second case. And now we move into the third case. Provided here the distance is constant. From the basic formula, we derive that the distance is constant. See, in the previous two cases, in the first case we have assumed that the speed as a constant one. In that scenario, if the speed is constant, distance is directly proportional to time. In the second case, we have assumed that the time is constant. So in such a case, again the distance is directly proportional to the speed. Whereas here, the distance is constant. If the distance is constant, then we cannot say that the speed and time are directly proportional to each other. It is not at all possible. Speed is always inversely proportional to the time taken. Isn't it? So speed is inversely proportional to the time taken. In the previous two cases, the distance is directly proportional to speed and the distance is directly proportional to the time taken. Whereas here, in the third case, if the distance is constant, the speed and the time are inversely proportional to each other. Just assume any scenario. Say, if I travel from my college to my home, to my residence, at a speed of 50 km per hour, say I can reach within half an hour. Whereas if I travel the same distance, at 100 kilometer per hour, isn't it? At 100 kilometer, that is, I am increasing my speed. If I increase my speed, automatically the time gets reduced. Similarly, if I decrease my speed, the time gets increased. So these two variables are always inversely proportional to each other. So if the distance is constant, then speed is inversely proportional to the time taken. So that is the ratio. How to compare these two variables? So the ratio of these two variables can be written as, see, S1 by S2 is equal to T2 by T1. I have not written as T1 by T2 because it is not directly proportional. As it is inversely proportional to each other, we have to write the relation as S1 by S2 is equal to T2 by T1. So the speed and the time are inversely proportional. So let us explain this case with an example. See here, the cyclist, he moves from his residence to his school at a speed of 10 km per hour, and the time taken by him is 40 minutes. Similarly, from the school to his residence, again the cyclist travels at a speed of 8 km per hour. So now if we observe these two cases, in the first case the speed is 10 km per hour, whereas in the second case the speed is 8 km per hour, which shows that he decreases his speed. So what about the time taken? So this is how the question will be asked. So in this case, what we have to do is, we know that it is very obvious from the scenario that the distance remains constant, isn't it? So we can directly say that the speed is inversely proportional to the time taken. So S1 by S2 is equal to T2 by T1. You know that S1 is 10 and S2 is 8. We do not know the time in the second case, so T2 remains the same, divided by 40. So now if you calculate the time, it is 50 minutes. See, if the speed increases, time decreases. If the speed decreases, obviously the time increases. This is very clear. So this is a perfect example for case 3. So these are the 3 cases which we must remember. So only depending on these 3 cases, we can solve the foregoing problems. And before we move into the problem, we have to see the units of measurement, because we have 3 different variables, say time, distance and speed. All these 3 variables are measured using different units. Say time we can measure in seconds, minutes and hours, and distance we can have meters, kilometers or miles likewise. Similarly, for measuring speed, we have again one or more units like miles per meter per second, kilometer per hour or miles per hour. So we have different units, and these units of measurement are also taken into consideration while solving the problem, because the distance may be mentioned in meters and the time can be given in hours. So we have to convert the problem into an appropriate unit so that we can arrive at an accurate answer. So this units has to be taken into consideration. And how to convert the units? So once we know the units, if they are given in a different way, then we go for converting into a common one. So the conversion of units plays a vital role here. See, 1 hour, again we know that it has comprised of 60 minutes, or we can say 1 hour is equal to 3600 seconds. Similarly, 1 kilometer is equal to 1000 meter. In other words, it is equal to 0.6214 miles. And 1 mile is equal to 1.609 kilometers. Or in short, you can remember that 8 kilometer is always equal to 5 miles. That is the difference between the kilometer and the miles. That is 8 kilometer is equal to 5 miles. And 1 yard equal to 3 feet, and 1 feet is equal to 12 inches. Some of the units or conversions what we need to remember. See, now I have to convert, because in one problem they'll be giving the units in kilometer per hour and asking us to convert in meter per second. So we need to convert the speed in kilometer per hour to meter per second. See, it is very simple. We know that 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 seconds. So divide this 1000 by 3600. Just by simplifying it, you will get 5 by 18. So if you want to convert kilometer per hour to meter per second, we need to multiply the value by 5 by 18. And the vice versa, the reverse case. Say if you want to convert from meter per second to kilometer per hour, bring this 5 by 18 to the left hand side, it becomes 18 by 5. That is for the reverse case. Similarly, 1 kilometer per hour is equal to 5 by 8 miles per hour. This thing also we need to remember. So these are the main conversions. So one is 5 by 18, and then the reverse case we have to use 18 by 5. And next, another important concept over here is average speed. See, average speed. How to calculate the average speed? What do that average speed meant for? See, we used to travel in a bike or a car at different speeds at different instances. We don't use the same speed to cover the distance, isn't it? For some time we'll be traveling at 50 km per hour speed, and for another time we'll be traveling at 40 km per hour speed. So our speed varies at different instances. So we can say that it is as an average speed. So if you want to know about the average speed, that is the average speed in which the car travels from hotel to the respective building or something like that. So we have to calculate the average speed over there. So average speed is always equal to the total distance travelled divided by the total time taken. This is the formula what we apply to calculate the average speed. That is total distance travelled divided by total time taken. See, in the first case, the average speed, that is the distance travelled. Here we have a car which travels from the hotel to the building. The total distance covered by the car is 100 km. Okay, and the time taken by the car is 2 hours. Now, to calculate the average speed, see, total distance is 100 and the time taken is 2. 100 by 2, which is equal to 50 km per hour. That is the average speed of the car in the first case. See, say for example, let us have the same situation in the second case, but with a slight modification over there. See, in the first case, there is no interruptions for the car. The car travels straight away from a hotel to the building. Whereas in the second case, again the same distance, but the car has to wait in one or more traffic signals, right? So in the first case there is no traffic signal at all, whereas in the second case we have an assumption that there is a traffic signal where the car needs to wait. So from the hotel to the building, again the total distance, the distance is constant, say it is 100 km. 100 km is the distance, but here the time taken by the car is 2.5 hours instead of 2 hours, because nearly 30 minutes the car has wasted because of waiting in the signals. It has one or more signals to cross over, so it has wasted 30 minutes in waiting. So here we need to calculate the average speed. See, while calculating the average speed, the time wasted by the car, that is waiting for the signals and whatever the case is, so that should be taken into account. We should not neglect that. So here the total distance travelled is 100, whereas the total time taken is not 2 hours, it is 2.5 hours. That is that 0.5, that is half an hour has been wasted by the car because as it has been waiting in the signals. So now the time taken by the car is 2.5 hours. Now the average speed is 40 km per hour. Here the average speed of the car is 40 km per hour, isn't it? So here also the car may be travelling at different speeds at different instances. Even then, since it has waited, again it has wasted some more time over there, so the time taken by the car, again it delays. Okay, so in the previous case it was not there, but in this case we need to consider that too. So here the average speed varies. So the formula what you have to remember to calculate the average speed is total distance travelled divided by the total time taken. Okay, now the first problem. So still now we were looking into the basics, some of the important concepts, and also the measurements and the conversion of units. So now the first problem is, what is the length of a bridge which a man riding at 15 km per hour can cross in 5 minutes? So now just we try to understand what is given, whether the distance or the time or the speed, whichever variable is given. So the rest we need to calculate. Here what is the length of the bridge? From the first line it is very obvious that we need to calculate the distance. So what is given over there? The speed is given and also the time is given. But again we need to observe very clearly that these two variables are given in different units. They are mentioned in different units. See, the speed is there mentioned in kilometer per hour, whereas the time is given in minutes. So either you have to convert the speed to meter per second, or we need to convert the time to hour, because since it is given in minutes, we need to convert minutes to hours. So the common we have to convert the units, that is very appropriate here. So the basic formula which we have seen earlier, the same formula we have to apply. There is no other formula in this concept. So this formula remains the same, that is distance is equal to speed into time. I'm going to convert the time to hours. So it is 5 minutes. If I want to convert this 5 minutes to hours, I need to divide that 5 by 60. Isn't it? Because 60 minutes is equal to 1 hour. So I am dividing the value by 60. Speed I can take as it is, because it is there in kilometer per hour. So 15 into 5 by 60, reduce 5 by 60. By cancelling it, you will get 1 by 12. So 15 into 1 by 12, which is equal to 5 by 4. So again, by simplifying it, you will get the distance as 1.25 kilometer. That is the length of the bridge. Okay, this is the length of the bridge, and this bridge can be crossed by the man if he travels at a speed of 15 kilometer per hour. Is that clear? And the second one is, Mukesh walks 10 kilometer in 5 hours. How much time will he take to travel 28 kilometer? See, in the first case, he walks 10 kilometers, so the distance is equal to 10 kilometers. Time is equal to 5 hours. The units are appropriate here, so there is no need for conversion. So let me directly calculate the speed, what he takes to cover this 10 kilometer. So speed is equal to distance by time. As I said, that distance and time and speed are inversely proportional to each other. So distance is 10 and the time is 5, 10 by 5, which gives you 2 km per hour. That is the speed of Mukesh. So if he walks at 2 km per hour, he could cover 10 kilometers in 5 hours. That is the time taken by Mukesh. Now, what was asked in the question? How much time will he take to travel 28 kilometer? So now you know the distance as well as speed also. We have calculated the speed. So from these two variables, we can easily calculate the time. So time is equal to distance by speed. So the distance what they have given in the problem is 28, and the speed what we have already calculated is 2. So 28 by 2 will get 14 hours. So altogether Mukesh will take 14 hours to travel 28 kilometer. Right? So these are very basic problems. And the next one, see, a 200 meter long train is moving at 60 km per hour. How long will it take to pass a pole? See, a pole or a standing man, everything, the objects are stationary objects. Okay, so we could not calculate the length of the pole or length of a standing man, because these two are stationary objects. So in this case, the main assumption what we have to make here is the length of the train. The length of the train is always equal to the distance travelled by the train. This is the assumption what we need to remember, because there is no length for a pole or a standing man. So in that case, the distance travelled is always equal to the length of the train. So here the same scenario. So here we need to have the same assumption. See, a 200 meter long train. So here the length of the train is given as 200 meter and the speed is given in 60 kilometer per hour. Just if you observe very clearly that the units are not the same, the units differs, right? And how long will it take to pass a pole? So they are asking you to calculate the time taken by the train to cross the pole if the train travels at 60 km per hour speed, right? So distance is equal to speed into time. So distance is given in meters and the speed is given in kilometer per hour. So we have to convert meter to kilometers. So 1 meter is equal to 1 kilometer is equal to 1000 meter. So 200 meter by 1000. I have to divide it so that I can convert meter to kilometer. That's why here I have divided 200 by 1000 for conversion, which is equal to speed is 60 into time. So just by simplify it, 1 by 5 equal to 60 into t, which gives you 60t. Keep the t in the right hand side, bring the 60 to the left hand side. So 1 by 5 into 60, just by cancelling it by 5, or simply you can retain the same, that is 1 by 300 is equal to t. 1 by 300 is equal to t. And suppose if the answer option, and also you have to check out with the answer options. If the time was given in seconds over there, but we are calculating the time in hours now, again from hours you need to convert it into seconds. So 1 hour is equal to 3600 seconds. So now I have 1 by 300th of hour. So multiply it by 3600. If you cancel it, then you'll get the value as 12 seconds. So that is the time taken by the train to cross a pole. That is 12 seconds. See, depending on the answer options, you go for conversion, or straight away you can give the answer as 1 by 300. 1 by 300, here the unit is hours, but in the answer option, it is mentioned, the units are given in terms of seconds. So we need to convert hours to seconds. That is the last step meant for, right? So third one. See, third one is another different model problem. Here, two trains start at the same time from A and B and proceed towards B and A, which means these two trains are traveling in opposite direction. That's what they are meant for. And at the speed is also mentioned here at 36 km per hour and 42 km per hour respectively. Okay, that is the speed of the first train, and the speed of the second train is also given when they meet. That is, at some point the train they are going to meet. It is found that one train has moved 48 km more than the other. What is the distance between A and B? So here from the question it is very obvious that these two trains are traveling in the opposite direction, and the speed of the first and the second train is also mentioned, and these two trains, they are supposed to meet at one point. At one point, I think one train has travelled 48 km, that is more distance when compared to the other. It happens because the speed varies, isn't it? The train which travels at higher speed may be crossing more distance when compared to the train which is travelling at a lower speed, isn't it? So somehow the train is meeting at one point. The speed of one train is greater than the other, right? Now what we are supposed to calculate the distance between these two stations, that is A and B. See, we are not going to apply any formulas over here. I'll give you a shortcut for solving this problem. See, the first train, one very smart way to solve this problem is, we need to understand the problem first. So the first train, the speed of the first train, here I have written the speed of the first train, which is 36 km per hour. Yes, and the speed of the second train is 42 km per hour. What is the difference between these two speeds? One is at 36 and another one is 42. The difference is 6 km per hour. Okay, the difference is 6 km per hour. So the difference of their distance is equal to 6 km. That is, in 1 hour, the faster train can travel 6 kilometers more than the slower train. Can you understand? In 1 hour, the faster train can travel 6 kilometers more than the slower train. Yes, if I am traveling at a speed of 40 kilometers per hour and you are traveling at a speed of 30 kilometers per hour, so what is our difference in speeds? In 1 hour, I will travel 10 kilometers more than you because my speed is greater. 10 kilometers per hour is greater. So in 1 hour, I can travel 6 kilometers. We used to say. Similarly, here also, the difference in speeds between these two trains is 6 kilometers. So the faster train will be covering certain kilometers, which is 6 kilometers more than the slower train. Yes. So the total difference, that is 48 by 6. So how many hours it takes to, because in the problem they have mentioned that one train has moved 48 kilometers more than the other. So 48 kilometers, to reach that 48 kilometers, how many hours the train would take? 48 is the distance and the time taken is 6, so cancel it, 8 hours. 8 hours is the time taken to cover this distance, right? So both the trains have travelled for 8 hours. 8 hours. So what is the distance travelled in that particular time? We know the speed and the time. We can calculate the distance because distance is equal to speed into time. So the first train time is 8 hours and the speed is 36 km per hour. See, I'll highlight here. And the second train, again the time taken by the train is 8 hours and the speed is mentioned as 42 km per hour. So multiply these two values and add it, you will get 624 km. That is the total distance between these two stations. It's a very smart way to solve this problem where we get answer very quickly. Rather, there are other approaches, but we need to elaborate it, and it also takes more time to arrive at an answer. So better we can follow this way, because once you understand it, just by using this logic, we can easily arrive at an answer. See, first we need to calculate the difference between these two speeds. Right, so the difference is 6 kilometer. That is, the faster train travels 6 kilometer more than the slower train in 1 hour. Okay, so the total difference is 6 kilometer is the distance. So the time taken is nothing but distance by speed. Distance is, they have mentioned that it is found that one train has moved 48 kilometer more than the other. So first, to reach 48 kilometer, you need to calculate how much hours it takes. It takes 8 hours. So in 8 hours, the first train travels this many distance, that is 8 into 36, and the second train travels this many distance, that is 8 into 42. So just by adding it, you will get the total distance traveled by these two trains. Next one, the problem based on the average speed. That is, a train running at the average speed of 30 km per hour covers a distance in 6 hours. Find the speed of another train which covers the same distance in 5 hours. Okay, there is one train and the average speed is given as 30 km per hour, and the distance, they did not mention the distance. We need to calculate the distance actually. In 6 hours, the time taken by the train is mentioned as 6 hours. So it takes 6 hours to cover that particular distance. And there is also another train which travels only for 5 hours. The distance is constant here. Okay, the distance is constant, and the second train travels for 5 hours, but the speed is not mentioned here. So the time is given and the speed is not mentioned, and they have also given a clue that the distance is constant. Yes, that is the case 3. Actually, this comes under case 3. And what is the assumption in case 3? If the distance is constant, then the ratio of their speed is inversely proportional to the ratio of the time taken. That is what we have already seen in case 3. Do you remember? Yes, the same thing we have applied for this problem. So the time taken, ratio of the time taken by the two trains, it is given. The first train takes 6 hours and the second train takes 5 hours. So I can write 6 by 5, which is, and the ratio of their speeds. How to calculate? The time is given. From the time you need to calculate the ratio of their speeds. So it is inversely proportional. So if the first train takes 6 hours, then the speed will be 1 by 6. Am I right? At the same time, if the second train takes 5 hours, so the ratio of their speed will be inversely proportional. So 5 by 1, if it is inversely proportional, I can write it as 1 by 5, reverse way. So if the ratio of time taken by the two train is 6:5, then the ratio of their speed is 1 by 6:1 by 5, since time is inversely proportional to speed. Or otherwise, I can put it another way, I can write it by cross multiplying it, we will get 5:6. So the time taken is 6:5, but the speed is equal to 5:6. It is very simple now. Now we are supposed to calculate the speed of the second train, isn't it? So what is the speed? What is the ratio of speed of the second train? It is 6. Ratio of speed of the second train, yes, it is 6. And what is the speed of the first train, which is 30 km per hour? So 30 into 6 by 5. 30 into 6 by 5. So just by cancel it, you will get 36 km per hour. That is the speed of the second train. See, 6 is the ratio, distance. Or else from the first equation also we can calculate. See, 30 km per hour is the speed. That is 30 into 6 by 5. 30 into 6 by 5. Cancel it, you will get 36 km per hour. That is the speed of the second train. And the next one, two men A and B walk from P to Q at a distance of 36 km at 7 km per hour and 5 km per hour respectively. A reaches at Q and immediately returns and meets B at a point R, at a place R. Find the distance between P and R. So it is very easy. From this line you can understand. See, there are 2 points. See the points. one is P and another one is Q. Okay, so two men, A and B, they walk from P to Q. Both are walking actually, P to Q. The P is the source and the Q is the destination where they have to reach at a distance of 36 kilometers. So the distance, the total distance is also given. The total distance between P and Q is 36 kilometers. Okay, you are clear with that. Next, and the speed of these two persons are also mentioned. Like the speed of the first person as 7 and the second one as 5. So, is it clear? Now, A is the first person. What he does is, he reaches the point, that is, he reaches the destination and immediately he returns. He returns to the starting point. So, while he returning, he meets the second person B, which means B has not yet reached the destination. So, but A has reached the destination and is returning back to the initial position. Meanwhile, he is meeting B at one point. That is the point which is mentioned as R. At one point. Now, we need to calculate the distance between P and R. This is the distance what they are asking for, right? So, now the distance from P, that is the initial position to the final position, is 36 kilometers. Now, what is the total distance covered? You have to calculate the total distance, because that person is returning now. After reaching the destination, again he is returning back. So, we need to calculate the total distance. Total distance, simple. So, in one way it is 36 kilometers. If we need to calculate the total distance, then it is 2 into 36. So, the total distance is 72, that is to and fro. The distance should be taken into account. So, the total distance is equal to 72 kilometers. Okay. Then the ratio of the speed, yes, that is also mentioned. That is the speed of the first person as 7 and the second one as 5. That is, ratio of speed of A and B is equal to 7:5. Right. So, now we need to find the distance between P and R. Therefore, that is PR is equal to, that is nothing but the distance travelled by the person B. This is the distance travelled by the person B. So, what is the ratio of speed of B? It is 5. Out of total parts, 12. So, 5 by 12 into what is the total distance, which is 72. Straight away we can arrive at an answer. Just calculate it. I think 12 into 6 times will give you 72. So, 5 6 are 30. Can you understand this? See, if you hear my lecture on ratio and proportion, I have clearly explained on this part. Okay. So, the ratio of the speed, this is the ratio of speed of the first person and the second person. Now, we are about to calculate the distance travelled by the second person, that is person B, is equal to, the second person ratio is 5, isn't it? Total ratio is 7 plus 5, which is 12. So, out of 12 parts, 5 parts. So, that is why it is written as 5 by 12 into the total distance travelled by the persons are 72. So, just by cancelling it, we will get 30 kilometers. So, that 30 kilometers is the distance between P and R. Yes. The next question is, if a man goes to a place at an average speed of 10 km per hour and then returns at an average speed of 15 km per hour, so find his average speed during the whole journey. That is, say for an example, if he travels from his residence to his office, while going is travelling at one speed, that is 10 km, whereas while returning is travelling at a higher speed, say 15 km per hour. So, we are about to calculate the average speed. It's very simple. There is a formula also. You can apply that formula, or we can simply say that the total distance travelled by the total time taken. You can apply that also. So, here I have given both the way. The formula, that is 2 into A into B divided by A plus B. So, 2 into A and B are the speed, the respective speeds, to and fro. So, 2 into 10 into 15 divided by 10 plus 15. So, cancel it, you will get 12 km per hour as the average speed. Or to put in another way, you can calculate the total distance travelled by the man, or else the distance as constant and the total time taken. Okay, but here it is not at all mentioned. I think we can straight away use this formula to calculate the average speed. Here 2AB divided by A plus B, where A and B are the average speed in to and fro direction. So, and the next one is another interesting problem. This kind of problem quite we come across in competitive exams. See, a truck travels at a speed of 64 km per hour heading towards town A. 3 hours later, a jeep traveling at a speed of 96 km per hour begins its journey from the same place. When does the jeep catch up with the truck? When does the jeep catch up with the truck? So they are asking the time when it catches the truck or overtake it. Right. So first, just look at the diagram. It is very clear that T for train and J for jeep I have indicated. See, the truck travels at a speed of 64 km per hour. It is also moving towards, that is both the train and truck and the jeep are traveling in the same direction. Yes, so both of them are heading towards some town, say A, and the speed differs. The speed of the truck is 64 km per hour and as well as the speed of the jeep is 96 km per hour, and provided these two objects, that is they are not starting at the same time. That is very important here. See, the truck has started earlier. 3 hours later only the jeep has started. We have to take into account, because if we understand this just by logic we can solve this problem. No need to apply any formulas here. See, the truck has started earlier. So when the jeep has started, 3 hours later a jeep started. But the speed of the jeep is higher than the speed of the truck. Okay. So within 3 hours, right? Initially only the truck has started at a speed of, see, I'll show you here. Yes, initially the truck has started at a speed of 64 km per hour. Within 3 hours the truck, it will not be in a starting position, it will be in some certain point, it has reached some certain distance, isn't it? So 3 hours, what is the distance covered by the truck in 3 hours if it travels at 64 km per hour speed? So you know the speed as well as the time taken. So speed into time, speed multiplied by time will give you the distance travelled by the truck in the 3 hours, right? And it is mentioned here. Is it clear? So initially both the truck and the jeep, see, listen, they are not starting at the same time. Initially only truck is starting, and yes, the truck, and it travels for how many hours? 3 hours. In 3 hours it travels a distance of 192 km. How we arrive at this 192 km? Speed into time. The speed of the truck is 64, time is 3. So 64 into 3 will give you 192 km. That is the distance travelled by the truck in 3 hours. So after 3 hours what happened? After 3 hours the jeep has started its journey. It begins its journey, and what is the speed of the jeep given in the problem? It is 96 km per hour. That is the speed of the jeep. So while the jeep was starting, where was the truck actually? The truck was at this point, say at point T. See, I am indicating over here. So here the truck is at the point 3. While the truck is at this point, the jeep is starting its journey, isn't it? So what is the remaining distance that is need to be travelled by the truck to reach the point A? This is the remaining distance. That is, already it is at the point T, say small t, from here to the station or to the town A. This is the total, this is the distance that is to be covered by the truck. Let me take this distance as small t. Okay, this is the distance. Okay, at some point the truck and the jeep, they have to meet, isn't it? So we need to calculate that one. That is the main. We are not going to calculate the distance traveled by the truck or the distance between the starting point and the final destination. No, this is not this is not we are supposed to calculate. We need to calculate when does the jeep catch up with the truck. So initially I assume that, see, there is one point I've shown you in the diagram that it is highlighted here. See, this is the point. We'll assume that this is the point where the jeep catch up with the truck. So to reach this point, what is the distance? Now what is the time taken by the jeep to reach this point? Similarly, we need to calculate the time taken by the truck to reach this point. We'll assume at one certain point, right? That is an assumption. So let me take this distance as t. Already the truck is here, so the remaining distance as t. So in this meantime, that is the truck has to travel this t distance to reach this point in this t hours. In the same t hours, the jeep has to reach this point. This t is common, isn't it? Then only the jeep can catch up with the truck. So this t hours, the t hours is common, but the distance varies. See, within t hours, the truck has to catch up with this distance. That is, already it has crossed 192 kilometer. So now it has to cross the rest of 192 kilometer in the t hours, whereas the jeep is now at the starting position only. Okay, so it has to reach this point in t hours. Okay, so now how we can make the comparison? See, listen. That is, the total distance traveled by the truck is, already it is 192 plus this is the time t, this is the speed into time is the distance, so 64 into t, so 192 plus 64t is equal to, what is the distance traveled by the truck? It is 96 is the speed and the time was t. We do not know the time, so let us assume that as t hours. Okay, so 96 into t, that is 96t. Just equate these two things. 192 plus 64t is equal to 96t. So bring t to one side and the variables to the other side and just calculate it. You'll get the value of t as 6 hours. 6 hours, right? So the distance traveled in 6 hours, what is the distance traveled? We can calculate. It's very simple. And speed is there, time is there. Speed into time will give you the distance. But they have not asked you the distance. They have asked, when does the jeep catch up with the truck? That is, after 6 hours, the jeep catch up with the truck. That is the final answer. Is that clear? And the last problem is, the distance between two stations, Delhi and Amritsar, is 450 km. A train starts at 4 p.m. from Delhi and moves towards Amritsar at an average speed of 60 km per hour. Another train starts from Amritsar at 3:20 p.m. and moves towards Delhi at an average speed of 80 km per hour. How far from Delhi will the two trains meet and at what time? So from this we observe that we need to calculate, the distance between the two stations is given, that is between Delhi and Amritsar is given, and there are two trains and they are travelling in opposite direction, that is also given very clearly. And the time, what about the time? They are not starting, both the trains are not starting at the same time. Say one train starts at 4 p.m. whereas the other one starts a little bit earlier, say 3:20 p.m. Okay, so the time also differs, but the distance is constant. The distance between the two stations is constant. And the speed, what about the speed? The first one from Delhi and moves towards Amritsar. No, the first train has an average speed of 60 km per hour and the second train average speed of 80 km per hour. So the time differs, the speed also varies, but the distance remains constant. Yes, these are the things what we infer from the question. And also we are supposed to calculate that is the time at which these two trains meet each other, isn't it? And also the distance. These two things we need to calculate. Okay. So I think in this diagram it is very clear. All the situations which is mentioned in the problem has been depicted here. See, yeah, the distance between Delhi to Amritsar, it is 450 km. Is that clear? Right. Now see that yellow mark. I have given you an yellow circle as well as a red circle. Okay, this is the first train. There is a train which starts from Delhi, and the red circle indicates the second train which starts from Amritsar. Right. So the first train, the speed of the first train is the speed of the first train is 60 km per hour, right? And the second one is 80 km per hour, and both are traveling in opposite direction, which the arrow mark indicates, right? And what about the time? See, the first one starts at 4 p.m. and the second one starts at 3:20 p.m. Okay, I'll give another method of solving this problem. Distance moved by the second train. Why we are picking up the second train first? Because it is starting a little bit earlier when compared to the first train, because it has started at 3:20 p.m. itself. So what is the difference between the time? First one has started at 3:20 p.m. and the second train has started at 4 p.m. So the difference is 40 minutes. So the second one has started 40 minutes earlier than the first train, and within 40 minutes it has been covered some distance also. It has covered some distance traveling at certain speed, and the speed is also given in the problem. So let us calculate that particular distance which is moved by the second train during that 40 minutes duration. That is why we are taking that 40 minutes, because only after 40 minutes the second train starts a journey. So let us first calculate the distance moved by the second train during that 40 minutes. So distance, again the same formula, distance is equal to speed into time. Here the speed is given, the speed of the second train as 80 and the time is 40 minutes. 40 is nothing but, again I'll repeat, that 40 minutes is the difference between these two times, that is 3:20 p.m. and the 4 p.m. That is 40 minutes. So we need to convert it into hour. That's why I have written 40 by 60, because the speed is mentioned in kilometer per hour. So the conversion of units is very important. So 40 by 60. Just by simplifying it, you'll get an answer, that is 160 by 3 kilometer. So 160 by 3 kilometer, that is the distance moved by the second train during that 40 minutes duration. So before the first train has started, the second train has already reached or already travelled 160 by 3 kilometer. Yeah, that is what we infer from this first case. Yes, now move to the problem. The second one is, so what is the total distance that is left to be covered? The total distance we know, isn't it? The distance between Delhi and Amritsar, that is given as 450 kilometer. Out of 450 kilometer, what is the distance we have already covered, which is 160 by 3. So the remaining difference, just subtract 160 by 3 from 450, you'll get the distance that is left to be covered, or the remaining distance. That the remaining distance is 1190 by 3. I'll keep it in fraction, it is easier for cancelling it. Okay. So the total distance left to be covered is 1190 by 3 kilometer, right? And what is asked in the question? After 4 p.m. What is the time taken after 4 p.m. to meet each other? Anyhow, at some point of time, the two trains are going to meet each other, and we need to calculate that time, isn't it? So the time taken after 4 p.m. to meet each other, that is equal to, this is the total distance that is left. So time is always equal to distance by speed. So what is the distance that is left to be covered? 1190 by 3 divided by speed. See, again in speed I have taken 60 plus 80. That is the relative speed. And why we have added the speed? Because these two trains are moving in opposite direction. If the trains are moving in opposite direction, then we need to sum up their speeds. That is, we have to add their speeds. So in case if the trains are moving in the same direction, then if we need to calculate their relative speed, then we have to subtract it, since they are moving in the same direction. But in this case, there are two trains which are traveling in opposite direction, so we have to calculate the relative speed. Relative speed is nothing but 60 plus 80. So time is equal to distance by speed, which is equal to 17 by 6 hours. So again, very accurately, if you want to say, it is nothing but 2 hours 15 minutes. So this is the time taken after 4 p.m. to meet each other. That is 2 hours 50 minutes. And they have asked the other point also. That is, two questions are there. We need to calculate the time and also the distance. So distance from Delhi where they meet is equal to distance from Delhi where they meet. That is, distance is equal to speed into time. We know the speed of the first train as 60 km per hour, and the time taken is 17 by 6. So just cancel it, you'll get 170 km. 170 km. So how far from Delhi they meet? That is, after 170 km, at the point of after travelling 170 km, the two trains meet each other. And what is their time of meeting? It started at 4 p.m. Right? It started at 4 p.m. and to reach that 170 km, it took 2.5 hours. So the time of meeting is 4 plus 2.5 hours, which is 6:50 p.m. 6:50 p.m. That is the time of the meeting, and the distance where they meet, that is at 170 km. See, straight away you could not write 250 as the time taken. Okay, already the train starts at 4 p.m. and plus once it has started at 4 p.m. and it has travelled 2.5 hours. That is 2 hours 50 minutes. Sorry, it is not 2.5. It travels 2 hours 50 minutes to travel that 170 km. So the time taken is 4 plus 2 hours 50 minutes, that is 6 hours 50 minutes. That is the time taken to meet each other. Is that clear? Okay, thank you.